Today's lecture is on probability 9-7. Um, the actual concepts are very simple. Once again, the hard part is actually doing the questions, right? So what is probability? Probability is defined as the number of desired outcomes over the number of possible outcomes. And that's it. My lecture's over, right?
That's fast.
Yeah.
Let's go. That's it.
This will be my shortest YouTube video yet.
Isn't it?
Okay.
You get more than 1 minute long to gain a position, so.
Yeah, I don't think I'm gaining too much. I should get some sponsors, Yeah. Maybe if you guys would subscribe.
I'm subscribed though. I'm subscribed.
All right, let me do some examples. So I'll do 1A and 1B. Okay, 1A. What is the probability of getting two heads after flipping a coin twice?
1/4.
Very good, Luna. You are correct. The reason is because, right, the number of desired outcomes is only one, because there's only one possibility of getting two heads. You have to get HH. However, there are 4 total outcomes because, right, we have 2 flips and there are 2 possibilities for each flip. So that comes out to 2 times 2 equals 4 total outcomes. So the answer is 1/4 for question A.
And 1B is 1/2.
Very good.
What 2A is 1/2.
Very good. Okay, let's do 1B. So 1B, what is the probability of getting one head and one tail in any order? Now we have 2 desired outcomes, right? It could either be HT or it could be TH. This is also 2 factorial, isn't it? So we have 2 desired outcomes and we still have the same total possible outcomes. So it's 2/4 equals 1/2. Questions? There's also a second way you could have done 1A, right? You could have also done 1A because we know that probabilities multiply when we have independent events. Okay, so what that means is that we can first calculate the probability of getting the first head, which is 1/2, and then multiply by the probability of getting the second head, which is also 1/2. So we have 1/4. However, this strategy does not work for 1B, right? And the reason is because they could be in any order. However, if you do the logic carefully, you can do it for 1B using this kind of logic, okay? So for the first coin, it doesn't matter. It could be either head or tail. So we have a probability of 1. But the second coin has to be the opposite of the one that we just got. So that's 1/2. That comes out to 1/2 for the second one. So, if you do the logic carefully, you can do it this way. But the more general, more reliable way is just to always do desired outcomes over possible outcomes. Let me also do 2B. 2B, okay? So if I flip a coin 5 times, what is the probability? Or actually, no, let me do a different one. Let me say we flip it 3 times. What is the probability of getting 2 heads and 2 tails? Sorry, 2 heads and 1 tail. Anybody have the answer? Order does not matter for heads and tails. So what's the probability of me getting 2 heads and 1 tail in any order?
1/8.
1/16.
1/8.
3/8. 1/9.
Yes, 3/8. The reason is because there are three possible desired outcomes. We could either have HHT, or we could have HTH, or we could have THH. So there are three possible outcomes out of 8 total outcomes. 8 because that's 2 cubed, right? Makes sense? So really this question, HHT, this question of 2 heads and 1 tail in any order, that's actually the same question as us asking how many ways are there to order the word HHT? And we did that a lot last class, right? It's 3 factorial over 2 factorial. Yeah? Times 1 factorial, sorry, technically. Make sense? So that equals 3. That's how we got 3 different possible orderings for HHT. Questions? Sometimes you also might need to use this technique called complementary counting. So you'll need to use that for 2C. Complementary counting means sometimes it's easier to count the not happening versus the happening. Make sense? Not make sense? Let me give an example. Let's say once again, we're flipping a coin 3 times. So 3 flips. What is the probability of us getting at least 1 head? So there are 2 different ways of doing this. The first way is to count the probability of 1 head, and then count the probability of 2 heads, and then count the probability of 3 heads, and then add them up. But that takes a long time, right? Instead, what you could calculate is what is the probability of no heads, and then subtract that from 1. Make sense? It's much easier to calculate the probability of there being no heads, and then subtract that from 1, and then we'll find that this is equal to 7/8. Right? Because the probability of there being no heads means that we get 3 tails, so that's the probability of 1/8. And so we subtract that from 1, we get all the remaining possibilities. And if it's not no heads, then it's at least 1 head. So it's 7/8. Okay, we can do 2A now, I guess.
Yeah.
Well, Luna already did it for us, so you listen to Luna. Any questions about 1 and 2?
Can you do B?
B? You do B.
I tried.
What's your answer?
Got 6 over 10.
Okay, boys, many AirPods in. What is the point of this? You guys don't have your phones anyways, right? Kenji,
Yes, yes.
this is like the generation after me. There's this, you guys just don't know how to take the AirPods out. I don't know what's the purpose of this. I'm a Gen Z, but you guys are like 5 years after me, right? So it's different. Aiden? Yeah. What do you think it is? 10 what? 10 can't be a probability.
Yeah, but it's because so HTT.
Yeah.
How many different ways? So in that case, 5 factorial over 2 factorial.
Yeah, that's 10. No, 10 is your desired outcomes. You didn't divide by the total number of possibilities, right? For 5 flips. This is not 3/8. You need to figure out the number of ways you can possibly get 3 heads and 2 tails. Because it can be any order. It could be HHHTT. It could be TTHHH. Right. So you need to figure out how many ways there are to order HHHTT.
Be the same as how do you predict? Like how many different ways can you order this? Pretty much,
This one?
it's, yes, yes.
Figure out the number of ways to not get at least one head, which means that's all tails, and then subtract that.
So for this one, we have 3 heads and 2 tails. Where do I go from here?
Figure out how many ways you can possibly get 3 heads and 2 tails.
Okay. And then once I do that,
You divide by 32 again.
you divide by 32.
Yes.
Why do you divide by 32?
That's the total number of outcomes for 5 flips.
Ah, because it's all okay. Thank you.
So then would it be, that's why having one over three.
Yep, because that means you have all tails, right?
Right, so then you do, so then it would be. That would be 31. How would you do this?
You're trying to figure out how many ways you can, essentially, how many ways you can scramble HHHTT.
Like find all the possibilities.
Calculate it. This is the same as last class, right? Pretend it's a word. 3 letters H, 2 letters T.
Is there a faster way to calculate it than just writing it?
Yeah, we learned this last class. It's 5 factorial divided by 3 factorial times 2 factorial.
Divided by 2 factorial?
3 factorial times 2 factorial. No. Even in the denominator. Yeah.
I actually don't know, I haven't done that.
Did you watch the lecture for last class yet?
Half of it.
You're gonna be lost if you don't get the last class. Sure, yeah.
Wait, are these correct?
Yep.
Also, do we have to simplify them every single time? Or do we leave it as like 10 over 32?
I will specify. If it's not specified, you should simplify.
Okay, then yeah.
Okay, let me do some questions from problem 3. So let me do 3A. What else should I do? No replacement. Okay, so once the card comes out, it doesn't go back in. Let's do question A. I'll do it in 2 different ways. So let's first do it in the method where we calculate the number of desired outcomes over the number of possible outcomes. So really, this is the exact same as last class. We're just now dividing things. Okay. So I could first ask you guys, if we have a 2-card hand, what is the probability? I'm not maybe. If you have a 2-card hand, what is the probability of getting 2 hearts? I could first ask you guys that. So how many ways can we get 2 hearts in a 2-card hand? We have 13 choices for the first card, because there are 13 hearts. And then we have 12 choices for the second hand, right?
Yeah.
And then we overcount, right? We overcount by 2 factorial, because there are 2 ways to order that hand. And so the total number of desired outcomes is 13 times 12 divided by 2 factorial. No simplifying for this question. How many total possible outcomes are there for a 2-card hand? That's going to be 52, not factorial, just 52 times 51 divided by 2 factorial, right? Because now we don't care about what kind of hand it is. We just care about all the possible 2-card hands.
Yeah.
And so the denominator is going to be 52 times 51 divided by 2 factorial. And we would just call that our answer. Yeah.
For 2, is it 5 or 16?
Yeah, so it's just 13.
5 over what?
16.
I mean, that's not a probability, once again, right? Probability has to be less than 1. 5 over 60?
Yeah, 16.
16? That seems too high, right?
Head over 35.
Oh, 2B? Oh, 2B, yes. There's a 3B. Nico?
Can't we just say it's 13 divided by 2 times 12 divided by 1? But yeah, 13 divided by 52 times 12 divided by 51.
Yes, that works. That's the second method I was about to tell you guys. Okay, the second method is very similar to the coin tosses, okay? We can simply ask ourselves, what's the chance of getting a heart on the first card? That is 13 over 52, right? Now, without replacement, what is the possibility of getting a heart on the second card? It's going to be 12 over 51. Because now there are only 12 hearts left and 51 cards remaining. No? Oh, yes, it is. Sorry.
Yeah.
And so our answer would be the same thing as before.
So is it not?
It is, but no simplifying. Which one should I do now? This is 3A. Let me now do 3D. Just for fun. Let me do 3D using my second method. So I have 5 cards. What is the probability of them all having different ranks? So that means they all have different numbers, essentially. What is the probability I should assign for the first card? I should just say 1, right? Because I don't really care about what the first card is. I just need to make sure the second, third, and fourth, and fifth cards don't have the same rank. All right, what is the probability for the second card? Anybody?
11 over 12.
4.
12 over
13.
12.
12.
It's going to be 48 over 51.
So
It's 48 because there are 48 cards with a different rank than the first one. Because I want to make sure I'm not repeating the rank. So for example, if the first card was ace, there are 48 non-aces remaining in the deck. Yeah?
Oh, wait, that's super.
What? There are 4 aces in a deck.
Wouldn't it be like 40, 13 rays? 30, what is it, 38? What would it be 39?
There are 48 non-aces in the deck and 51 cards remaining. Okay, what's the next probability? Good. 44 over 50, because now I want to make sure I'm not repeating the second card as well. So there are 11 ranks remaining and 4 of each rank. And 40 over 49 and 36 over 48. And that would be the answer. Got.
This doesn't know how to.
Okay, and the back page is very fun because on the back page, I'm having you calculate the probability of all the major poker hands. And so you should get answers with decreasing probability. So we start with pair, then 3 of a kinds, then straights, flushes, full house, 4 of a kind. And those are the orders of poker hands from least to greatest, right? So that's fine. It's not something you learn, I think. I think you just have to be a genius, which I'm not. I enjoy poker, yeah.
Blackjack. But it's not. More.
Poker, 2 cards. I'm trying to say just all.
So I'm just saying that we have some posts.
Yeah, you have 7 cards.
Find break or.
Break.
I keep hearing wrong, like,
Like, yeah, it's okay. Oh. Going. I mean, exactly. You're not going.
In blackjack, I mean, it's something.
What's the chance?
That's